Okay, so imagine this. You're a scientist, and you've just discovered a brand new compound that stops a virus dead in its tracks. I mean, this is a huge deal. But then comes the big question, the really hard part. How is it actually working? Because to turn that discovery into a real medicine that helps people, you have to know its secret.
And that's the exact puzzle that lies at the heart of all antiviral drug development. Finding something that works is one thing, but figuring out its mechanism of action, its specific game plan against the virus, that's the real key. And that's exactly the puzzle we're going to crack today.
So, how do we do it? Well, we have a really elegant tool for the job. It's called the time of addition assay. Think of it like a detective's secret weapon, letting us pinpoint the exact moment our new antiviral drug steps in to do its job.
Now, what you're seeing here is basically the whole roadmap for our investigation. I know, it might look a little complicated at first glance, but don't worry about it. We're going to walk through this whole thing step by step, and you'll see exactly how each part helps us get to the answer.
First things first, before we can test our antiviral, our main suspect, we have to set the stage. You can think of it like we're preparing a crime scene for analysis. We need our potential victims, which are the cells, and our perpetrator, the virus, all ready to go in a controlled environment.
The setup itself is actually pretty straightforward. First, we do something called cell seeding, which is just a fancy way of saying we grow a nice, healthy layer of cells in a dish. They're our happy little community. Then we introduce the virus, which is going to try to infect them and multiply.
Okay, and this is where the real genius of this whole technique comes in. We are going to add our potential drug at 3 totally different, very specific times. This is how we catch it in the act, because with this assay, timing is literally everything.
So our first scenario is what we call pre-treatment. For this one, we add our antiviral compound to the healthy cells about 2 hours before we even let the virus anywhere near them. We're basically giving the cells a protective head start.
So what's the question we're trying to answer here? Well, we're asking, does our drug act like a bodyguard for the cells? Does it fortify them, maybe block the little doorways, the receptors, that the virus needs to use to get inside? Basically, we're testing to see if it's a viral entry inhibitor.
All right, on to our second timeline, co-treatment. Now this time, we don't give anyone a head start. We add the virus and our drug to the cells at the exact same time. They both arrive at the battleground together.
The question here is just a little different. We're wondering if the drug works by interfering directly with the virus itself, right at that crucial moment of attack. Does it, grab onto the virus and neutralize it? Or does it jam the lock and key mechanism right as the virus is trying to get in?
And that brings us to our third and final condition, post-treatment. In this scenario, we let the virus win the first round. We let it infect the cells, get inside, and start setting up its little replication factory. Only after all that has happened do we add our drug.
You see, this is testing a completely different strategy. The virus has already breached the walls. The question now is, can our drug work from the inside? Can it sneak in and shut down the viral factory that the virus is building to make copies of itself? This is how we find out if we have a replication inhibitor.
Okay, so we've run our 3 experiments, we've let everything incubate, now it's time to put on our detective hats and analyze the evidence. How do we actually see if our drug did anything at all? Well, the evidence we're looking for is called a viral plaque. A plaque is basically a dead zone. It's a clear spot on our layer of cells where the virus has successfully infected, multiplied, and destroyed all the cells around it. So, the bottom line is, more plaques, bad. That means the virus won. Fewer plaques, good. Our drug is working. So our job as the scientist is pretty simple, really. We just count the plaques in each of our 3 conditions. Then we compare those numbers to a control dish that had the virus but no drug at all. The condition that has the lowest number of plaques, well, that tells us exactly when our drug is most effective.
Let's look at some pretend results to see how this works. Our control dish, the one with no drug, has about 100 plaques. That's our baseline, a full-blown infection. Now look at the before infection condition. Whoa, only 10 plaques. That tells us the drug was super effective when we added it first. But then look at the other 2 conditions. They have almost as many plaques as the control. This right here is our smoking gun.
So, we've collected the evidence, we've analyzed it, and now it's time for the big reveal. The verdict is in. What did we actually learn about our mystery compound?
And this is the real power of the time of addition assay. Because our drug only worked when we added it before the virus, we can say with a lot of confidence that it's a viral entry inhibitor. It's the bodyguard, right? It blocks the door so the virus can't even get inside.
Now, if it had only worked when we added it after infection, we'd know it was a replication inhibitor, sabotaging the factory from the inside.
So, to wrap it all up, this one, single, elegant experiment tells us so much. It reveals our drug's secret strategy. Is it blocking the door, or is it shutting down the factory? And pinpointing this specific stage of infection is an absolutely essential step in developing new and effective medicines.
And that just about does it for our explainer. But I want to leave you with one last question to chew on. Based on everything we've talked about, what if the results were different? What if the drug was only effective in that middle co-treatment condition? What kind of mechanism might that point to? Think about it for a bit, and you'll realize just how much you've learned today. Thanks for joining me.